In this video, we're going to go over the properties of the logarithms. Okay, so like we have exponent rules, we have logarithm rules. So here is a list of the most useful ones. So the first one, if I want log base A of the number 1, so maybe at the top here I'm just going to remind us that y equals log base A of x if and only if a to the y is equal to x. Okay, so we're going to be using that quite a lot. So to determine log base A of 1, we want to know a to what power equals 1. Okay, and obviously that power has to be 0. So if you take log, no matter the base, log of 1 is going to be 0. Okay, now similarly, if I want log base A of A, so that's a to what power is equal to a. Okay, and this is a to the 1, so clearly the question mark here is 1. Okay, so this is going to be 1. So similarly, if I have log base A of a to the x, this is going to be x, since, okay, so if y is equal to log base A of a to the x, if we use our transformation, that means that a to the y is equal to a to the x. These guys have the same base, so that means that x has to be equal to y. Okay, and y was our log, so then our answer is x. Similarly, a to the log base A of x. So remember what log base A of x means. It's the exponent we need to raise a to in order to get x. Right, so that's what it looks like up here. So y is the power that I need to raise a to get the thing inside, which is x. So if I actually raise a to that power, I better get x, because that's what it means. Now if I have log base A of m times n, this is actually going to be log base A of m plus log base A of n. Okay, now I'm just going to give you a little proof here so you have some idea. All of these rules are coming from the exponent rules. Okay, so if we let y be log base A of m and x be log base A of n, then by the rule at the top we know that a to the y is equal to m and a to the x is equal to n. Okay, so log base A of m times n is log base A of a to the y times a to the x. Now because of the exponent rules, this is log base A of a to the x plus y, and then using the rule 3, I guess, up there, this is equal to x plus y, which is log base A of n plus log base A of m. Okay, so that's why that one's true. The division one is the same, okay, so I'm not going to prove this one, but it's going to be log of the top one, minus log of the bottom one. So this one's kind of neat. Here I have log base A of m to a power. So when you have this, what you can do is drop the power to the front. So this is actually r times log base A of m. Okay, so the reason why here, so if, let's say, x is equal to log base A of m, that means that a to the x is equal to m. And if we raise both sides to the power r, that's going to be a to the x to the r is equal to m to the r. So m to the r is a to the r times x, which means log base A of m to the r is log base A of a to the rx, because m to the r equals that, which is r times x. And x was the log. Okay, so that's why you can bring that down. It only works if the power is on everything inside the log. Okay, so that's the only time you can do it. Now, as with exponential functions, when we have the same base, okay, and the two logs are equal, we can conclude that the insides have to be equal. Okay, so that's because log is a one-to-one function. So a note here, just like the square roots and the powers and everything, if you have addition inside, log base a of m, that doesn't really look like an m, so of m plus n, this is definitely not equal to log base m plus log base a of n. Okay, definitely not equal. It's also not equal to, say, log base a of m plus n separately. Okay, definitely not. It's stuck like this. So you won't be able to simplify unless you can factor something out, because then if you have multiplication, then you can break it up. Okay, so don't try, and the same with minus. Okay, so if the plus and minus inside the log, that's stuck like that. Okay, so let's do, using these rules a bit, I'm going to only do a couple of these. So let's do the first one. So 2 to the power log base 2 of 3. This one has to be 3. Okay, so as I mentioned before, log base 2 of 3 is the exponent we need to raise 2 to in order to get 3. So if we raise 2 to that power, we should get 3. Okay, this also is because the exponential and the log are inverses, so they sort of cancel out. Okay, the next one I'm going to do is part E here. So I'm going to leave B, C, and D for you. They shouldn't be too challenging. So here I have addition of logs with the same base, so I can use the product rule to put them together. So this is actually log base 6 of 4 times 9, or log base 6 of 36. Okay, now 36 is 6 squared, so that means that this is a 2. So the exponent I need to raise 6 to in order to get 36 is 2. Okay, now we could also, so like we did that, we can combine logs with x's in them. So we want to write this as a single logarithm. Okay, so all of these multiples of the logs, what I can do is I can bring them back up. Okay, so this is going to be ln of x squared minus ln of x minus 1 cubed plus ln of x plus 2. Okay, and then if I want, I guess I didn't need the arrow, so this is equal. Okay, so then this whole expression is equal, so I could take these two. Okay, when I have subtraction of lns, that's like division inside. So this is actually x squared, ln of x squared over x minus 1 cubed. Okay, and then when I have addition of logs, that's multiplication. So this is like over 1. I'm going to have to multiply fractions here. So what I'm going to get is ln of x squared times x plus 2 all over x minus 1 cubed. Okay, so now I have the whole thing written as a single logarithm. I'm going to leave example 3 and example 4 for you to do. So 4 is very similar to the one we just did. Example 3 is actually going the other direction. So I have it as a single logarithm, and you want to break it up as much as you can. So another log rule is the change of base formula. So if I have log base a of m, but I want the log in a different base, so for instance base e or base 10, because my calculator can handle those ones, what I need to do, so I can switch to log base b of m, so I can use for any base b. Okay, so I can switch it as long as I divide by log base b of the base, the old base. Okay, so that's the change of base formula. So yeah, the reason why this is useful is to mainly to switch to base 10 and base e, so your calculator can compute them. So let's just do one of these. So my calculator doesn't do log base 2 of 7. Oops. So what I would do is switch it, and I'm going to switch to base e, so that's ln. So it's going to be ln of 7 divided by ln of 2. Okay, and if I compute that, you're going to get approximately 2.807. So that's rounded to 3 decimal places. Or you could have switched to base 10, and then it would have been log base 10 of 7 over log base 10 of 2. Again, same answer. Okay, I'm going to leave example 6 for you to do. And that's all we have for the properties of log rules, or log equations. So in the next section, we're going to use some of these to help us solve some more log equations and exponential equations.